All right, thank you very much. Yeah, I'm Georgi. I'm the founder of Überblick, and as Jörg said, we are a technology company. So by technology company, I mean we build technology that helps other people build better products. So sometimes we build products our own, like iPhone apps and stuff, but most of the time we think about how people who build digital products can make their products better if they had access to technology, and our specialty is technology around aggregating, integrating, connecting data. I want to start with a story. It's a story about a drug, a quite popular drug. You might all know it because you get a lot of spam about it in your email inbox. It's Viagra, these small little blue pills. The story behind Viagra is quite interesting because it was originally developed and designed to be a drug that helps people with heart diseases. And only in the first clinical trial, they found out that, well, although it does improve the flow of blood, it's not quite happening where it's supposed to happen. But how the researchers call this using a drug in a different contexts and to treat people with a different disease than they originally thought, extension of indication. And Viagra is one example of this. When I was working as a researcher in an academic group here in Berlin, we were specialized in researching how we can integrate and connect data that's publicly available on the web. And one of our partners in a research project was a pharmaceutical company from the US. And they had like a hint that there was this existing drug that helps people overcome the nicotine addiction. So if you're a smoker, you can take this drug, and it will help you to smoke less. But the researchers at this company had found out that it could be that this drug also helps Alzheimer patients to deal with their disease. And our task was, can we find some indications in publicly available research that maybe not proves that, but that gives the researchers, the chemists, some indication where they need to look to find more information about this and to test this with patients. So what we did was to look for publicly available data that kind of connects well with this area, and we found here on this diagram you see 3 other data sources with information about this, but there were in fact there were a couple of more. And by connecting them, we were able to see that this drug affects, and now I'm probably going to tell this wrong, but it's almost true. I'm not quite sure how it works from a chemical perspective, but somehow it affects a gene, and for this gene there's a genetic disorder which people think might cause Alzheimer's. So you find in publicly available information links that connect these 2 entities together. But usually you wouldn't see this because the information is sliced into channels where you can only see the genes. So you have an internet portal that just shows you information about the genes, but not about the bigger context. And it's something that we as consumers are quite used to. It is how we look at most of the information in our life. This is an electronic program guide. This is what you see when you turn on your telly in the UK. And it tells you that tonight on BBC One, you can watch these TV series or programs. On BBC Two, you can watch these. On Channel 4, you can watch these. This is what we used to because, like 40 years ago, in the evening, we would turn on the television and we would decide, do we want to turn on BBC One or BBC Two? And that was the decision to make, and then we sit in our chairs and watch this channel for the rest of the day. But nowadays, it's not quite how we want to consume this. What we want to do is we want systems that are smart enough to tell us, hey, here are programs you might be interested in. And one distribution channel to get this program might be BBC One. Another might be Netflix to watch it on demand. Another might be go to the Blockbusters or Video World around your corner and get the DVD. Another might be ask a friend. He has a DVD at home. Or go to the cinema. So it's different channels, still different distribution channels for the same piece of content, but organized around the object and the entity that's of interest for us and not around the channel. When I left the research group and started Überblick, one of the organizations that we worked with was the BBC. And I'm going to use two example projects they've done as kind of very extraordinary, as I think, examples of how to organize information around the things and aggregate everything that's interesting, or the context that is interesting around that. This is the BBC Wildlife Finder. It's a project by the BBC where they want to make all the information they have about animals and plants and all the video footage they have in their archives available to everyone on the internet. So in the screenshot here, what is BBC and BBC Asset are all these videos here, and this beautiful picture of a giant panda. But the rest of the information on this page is not really BBC Asset. It's not BBC information. It's something they aggregated from around the web. So the map here, this here, come on, is from the WWF. Down here, you see other information that they license from other partners. You see links to content elsewhere on the BBC, and you see links to content elsewhere on the web about the same object. Another group within the BBC even went one step further, and that is BBC Music. And they chose not to build their website around their own asset, but to build a website around an asset that is owned by the community in the web. That asset is MusicBrainz. MusicBrainz is like a Wikipedia for music data. So you have a community of music lovers who go to MusicBrainz, and they manage and they maintain a large database of audio musicians and albums in the world. And before that, the BBC had their own database of music. But they figured, rather than maintaining this database very expensively, let's contribute towards MusicBrainz and use MusicBrainz as our reference point and build our website around that external data source and have our people contribute to that so that, well, on the one hand, our websites get better, but the community around MusicBrainz also has benefit from that. And that is something I think is a fundamental change in how you build digital products around information that is not your own information. And it's something that the web really enables. Yeah, and if you, on this website, this is Wikipedia information, this is BBC information. Here you see where the artists are played on BBC radio programs. And if you click through the album, this is MusicBrainz, this is MusicBrainz, this is a review by the BBC, and this is contextual information as well. So it's really a very rich aggregation of content designed for the user to have the most interesting information in one place. But this information really comes from many different places. So we thought about how we could do something like this for mobile and for local location-based services. For a very trivial task of how do I find a nice restaurant to go to, there are so many different services available that enable you to find this. So you can use Facebook to find information about the place. You can use Foursquare to find out if your friends ever went to this place. Or you can use review sites like Quip and Yelp to get reviews that the community wrote about that. But it's a tedious process of going through all these different applications to find out if a venue is for you or not. So what we tried is to aggregate all this information and come up with an interface that displays that in a more easy to use and then hopefully more beautiful way to the end user, where when you find it in a restaurant or bar or something where you can go and have food, it shows you all the different pieces from the different sources from around the web in one page, just like the BBC Music website or the BBC Nature website showed you everything about one object from around the web. We do that for location-based information. And that's an app we launched a couple of weeks ago for the iPhone. It's called Urbany. So a friend of mine, Moritz Stefana, did a project with friends of ours at the German press agency to look at how you can move up the aggregation kind of layer one step further. So what I've shown before was, let's aggregate everything about one object. What happens now if we aggregate these objects into something hopefully more meaningful? This visualization shows news stories on a map. It's pretty easy. But if you drill down into a city and you see a timeline, you really start to see patterns. You see what's happening across Germany around the day. And that's very interesting. And because we had similar kind of information, activity information, that we crawled from around the web for the Urbany project, we tried to come up with something similar. Let's look at if we can find patterns in the social activity data that we see on the web. So this is an experiment where we put all the activity information that we see at places on a map of Berlin. And the question was, can we reconstruct the most popular neighborhoods in the city just from this activity? Anyone from Berlin here? Who's from Berlin originally? OK. So you might recognize that, for example, here is Bergmannstraße. Bergmannstraße is a very strong, dense neighborhood with a lot of activity. Here's Potsdamer Platz. This here is Friedrichstraße. So you can almost see the street constructed just from the social signals from around the web. You have Torstraße, you have Hackescher Markt, this is Kastanienallee, over there is Prenzlauer Berg. Here's the Kurfürstendamm, and nothing of this is there's no, although we show the map in the background, the data is not constructed from a map. It is really, this is where the activity happens when people use Foursquare, Facebook, Quipe, and Yelp and such. And an experiment to go one step further is, can anyone guess what city this is? Yeah. Yes, it's Cologne. Thank you. It's good that it's recognized. We try to, this is not a visualization that you would show to an end user. It's just at the edge of aggregated enough that you can start to see the patterns, yet it is very raw. It's very raw data. If you would show this to an end user, you would probably aggregate a bit more on top. But the interesting bit here, the bits that I want to interest you in, are these green dots. We run pattern analysis on the data to try to find if we can find signals in the data that indicates tourist activity. Without looking at keywords, without looking at the reviews and looking for words like touristy, just from patterns, what time, what people check in, how often, across which services and how they group together, you see that a lot of green dots show up here in the middle, in the Altstadt of Köln, where all the tourist sightseeing attractions are. So you can actually find, if you run a bit of data analysis, you can find very interesting stuff in the data if you aggregate it together in a meaningful way. So you might say, well, OK, it's a pretty looking map, but I could draw this as well from hand. And indeed, you could ask someone who knows the city to draw a neighborhood, a map of all the neighborhoods in Berlin. But the thing is, my data, me as a Facebook user and Foursquare user and Quipe and Yelp user, and all of your data, if you are a user of one of these services as well, is in this picture. So you and us and me, we are part of the data that went into this analysis, which means that this is really context information about our behavior. And you can start to tailor this visualization to your own taste. I go to, well, like this neighborhood and this neighborhood and this neighborhood. I would never go there. It's just not my neighborhood. And if you look at the data in there that's coming from my friends and people with a similar taste to myself, you will see that this neighborhood here is starting to fade out. And the other ones where I actually would go to become bigger. And that is something that a static map cannot do. This is a personalization and a context for you that a static map can never deliver. So if you think, is this like some strange future, or is that real today? And how do we design for that? If you create your next, or if you think about when you created your last digital product, maybe an iPhone app or something like that, think about how you address the problem of entering your contacts into an application. Would you these days have a screen that says, your address book is empty, please now enter all your contacts into this application? You probably wouldn't. You would say, hey, import all your data, import all your addresses and contacts from your iPhone address book, or import them from Foursquare, from Facebook, or from LinkedIn. So we're already very used to pulling in information around the web into our applications for social graph. And I believe in the future we're going to see much more examples where applications can do that not only for contacts and social graphs, but for all kind of information that fits as context for that product. So we need to become not only part of data on the web, but of really a web of data that is connected together. I just wanted to show this picture. I think it's good. There's, of course, a meaning in this, of course. There are many meanings in this. I think how this fits into the context is, even if you see like too much signal in data and in information, if you have someone who can like tell you which angle to look at it, you will see only the pieces that are interesting to you, even though overall it can be confusing. But if you look at it from the right perspective using the right tools, it will be meaningful. And that is it. Thank you.